If the government or NASA had said to you that the Earth is stationary, imagine that. And then imagine we are trying to convince people that no, it's not stationary. It's moving forward at 32 times rifle bullet speed and spinning at 1,000 miles per hour. We would be laughed at. We would have so many people telling us, "You're crazy. The Earth is not moving." We would be ridiculed for having no scientific backing for this convoluted moving Earth theory. And not only that, but then people would say, "Oh, then how do you explain a fixed, calm atmosphere and the sun's observable movement? How do you explain that?" Imagine saying to people, no, the atmosphere is moving also, but is somehow magically velcroed to the moving Earth. The reason is not simply because the Earth is stationary. So what we are actually doing is what makes sense. We are saying that the moving Earth theory is nonsense. The stationary Earth theory makes sense, and we are being ridiculed. You've got to picture it being the other way around to realize just how ridiculous this situation is. This theory from the government and NASA that the Earth is rotating and orbiting and leaning over and wobbling is absolute nonsense. And yet people are clinging to it tightly, like a teddy bear. They just can't bring themselves to face the possibility that the Earth is stationary, though all the evidence shows it. We feel no movement. The atmosphere hasn't been blown away. We see the sun move from east to west. Everything can be explained by a motionless Earth without bringing in all these assumptions to cover up previous assumptions gone bad. If you find from your own experience that something is a fact and it contradicts what some authority has written down, then you must abandon the authority and base your reasoning on your own finding.
Foucault's pendulums are often quoted as proof of a rotating Earth, but upon closer investigation prove the opposite. To begin with, Foucault's pendulums do not uniformly swing in any one direction. Sometimes they rotate clockwise and sometimes counterclockwise. Sometimes they fail to rotate, and sometimes they rotate far too much. The behavior of the pendulum actually depends on 1. The initial force beginning its swing, and 2. The ball and socket joint, which most readily facilitates circular motion over any other. The supposed rotation of the Earth is completely inconsequential and irrelevant to the pendulum's swing. If the alleged constant rotation of the Earth affected pendulums in any way, then there should be no need to manually start pendulums in motion. If the Earth's diurnal rotation caused the 360-degree uniform diurnal rotation of pendulums, then there should not exist a stationary pendulum anywhere on Earth.
The Foucault pendulum is an assumption. It's an assumptive belief, assumptive theory, and assumptive proof that the Earth spins, and that's what causes this thing to move, usually in a clockwise position as it moves throughout the day. But did you know sometimes it moves counterclockwise? Did you know it almost always moves at different speeds? And as I showed here, a man named Elias discovered that when solar eclipses occurred, that the Foucault pendulum would drastically change its pattern and actually even reverse many times during a solar eclipse.
Throughout thousands of years, the same constellations have remained fixed in their same patterns without moving out of position whatsoever. If the Earth were a big ball spinning around a bigger sun, spinning around a bigger galaxy, shooting off from the biggest bang, as NASA claims, it is impossible that the constellations would remain so fixed. Based on their model, we should, in fact, have an entirely different night sky every single night and never repeat exactly the same star pattern twice. If Earth were a spinning ball, it would be impossible to photograph star trail time-lapses turning perfect circles around Polaris anywhere but the North Pole. At all other vantage points, the stars would be seen to travel more or less horizontally across the observer's horizon due to the alleged 1,000-mile-per-hour motion beneath their feet. In reality, however, Polaris's surrounding stars can always be photographed turning perfect circles around the central star all the way down to the Tropic of Capricorn. It would actually be impossible for star trail photos to show perfect circles even at the North Pole. Since the Earth is also allegedly moving 67,000 miles per hour around the Sun moving 500,000 miles per hour around the Milky Way, and the entire galaxy going 67 million miles per hour, these four contradictory motions would make star trail time-lapses all show irregular curved lines. If gravity magically dragged the atmosphere along with the spinning ball Earth, that would mean the atmosphere near the equator would be spinning at over 1,000 miles per hour. The atmosphere over the mid-latitudes would be spinning around 500 miles per hour, and gradually slower to the poles, where the atmosphere would be unaffected at 0 miles per hour. In reality, however, the atmosphere at every point on Earth is equally unaffected by this alleged force, as it has never been measured or calculated and proven non-existent by the ability of airplanes to fly unabated in any direction without experiencing any such atmospheric changes.
As you say, the globe is spinning at 1,000 miles an hour. Neil deGrasse Tyson, who's a leading astronomer in America,
I'm Neil deGrasse Tyson, bitch.
Tells us that the Earth is not a perfect circle, it is actually an oblate spheroid. It's squashed and wider at the equator. Yeah?
So Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere, it's oblate, and officially it's an oblate spheroid. That's what we call it.
So my question to him would be, why is there land at the equator? Because water will move more readily than rock. So if the Earth is spinning, the water will be collected at the equator. I mean, if you spin a wet tennis ball, okay, you spin a wet tennis ball, the water shoots off at the equator, essentially. So all the water will be gathered around the equator. So why is there land at the equator? Doesn't make any sense.
So imagine this is the ocean floor down here. This is the top of the ocean. And again, if you think, well, this is in a closed container, that's why. Fine. Fill up a swimming pool with water. Take a square one, a rectangular one like this rectangular here, and tell me if it acts like this, because as soon as that water gets in there, it's subject to the rotating force of the Earth, is it not? Is not this thing, this water in here, subject to the same gravitational forces as are on the Earth? I mean, this experiment isn't being done in outer space. It's not being done on a little spacecraft or something like that that's out there somewhere. This is on the Earth, exact same forces of the Earth, except for the spinning action we're going to show here is going to be much slower. And let's watch what happens. And let me mute it because the sound doesn't matter. That's another thing to get into, sound. And how sound moves 750 miles per hour, but we're able to speak to somebody to the east as much to the west. Look at that. Look, and we're going to see this slower. The horns of water is what everybody would call it, because every container that held water would have horns like this. From the glass holding in your hand of water to the ocean. Look at that. Is that what you see in nature?
The other thing is that, you know, we have senses to be able to sense acceleration. You know, you get in a car and somebody puts their foot down, you know, and you get thrown back in your seat. You can feel the acceleration. Yeah, you can feel changes, very minute changes of acceleration. So how is it that if you live up here in Macedonia, yeah, which is spinning at maybe 700 miles an hour, yeah, because the speed it's spinning is slower than this speed. So if you took a flight down to Africa, yeah, on the equator, why don't you feel the change in acceleration? Yeah, so why don't you feel the change in acceleration? You know, you have these senses that will register the slightest change, yeah? But you get off the plane there and you don't feel dizzy, you know, because now you're moving a lot faster. So, no, it doesn't make sense.